Let's use the rational root theorem to list possible rational roots to this polynomial equation. 1, 2, 3, and 6 are the factors of the numerator. And now I'm going to go to the leading coefficient and also list the factors of 1, 2, 4, 5, 10, and 20. So we have a lot of different possible rational roots. Well, I know that I could start by testing 1, -1, 2, -2, 3, -3, and 6 and -6. Like those would all work. And then I would start by testing 1/2, -1/2, right? 3/2, -3/2, until I find 1. So I'm going to go ahead and list all the possible rational roots, even if it takes me some time. So 1 and -1, 2, -2, 3, -3, 6, -6. Now I go to 2's. So I have 1/2 and -1/2. Now 2 over 2 reduces to 1. I have 3/2 and -3/2. And 6 over 2 reduces to 3 and -3. Let's move on to the next denominator. I have 1/4 and -1/4. 2 over 4 reduces to 1/2. And then I have 3/4 and -3/4. And I have 6 over 4, which reduces to 3/2 and -3/2. Okay, let's move on to 5's. I have 1/5 and -1/5. Then I have 2 over 5 and -2 over 5. And then I have, ooh, it was ugly. I have 3/5 and -3/5. And I have 6/5 and -6/5. Moving on to 10. This is a lot. I have 1 over 10 and -1 over 10. Now I know 2 over 10 reduces to 1/5. I've already listed it. I have not listed 3/10. So I have 3/10 and -3/10. And 6 over 10 is going to reduce down to 3/5, and I've already listed that. So we don't have to list anything that's already been covered above. Oh, let's go on to 20. So when the denominator switches to 20, I have 1 over 20 and -1 over 20. 2 over 20 is going to reduce down to 1/10. 3 over 20 we need to list. It's not on there, and it can't be reduced. And 6 over 20 is going to reduce down to 3/10, which we already have. That is a lot of rational roots. I just want to find one that works. Once I find one that works, I can take what's left below the synthetic division, and then I can work with that to try to solve. So I'm going to start by trying all of these to see if it works. And to save time on this, that's a lot to test. I'm going to find out which one works, and I'll be right back with you. All right, we've got problems. I went ahead to save time on this video, and I tested 1, -1, 2, -2 using synthetic division, 3, -3. I tested 6 and -6, and there's a problem. None of these work. So yes, these were possible rational roots, but none of them worked. So now I have to start using fractions. Let's start with +1/2. So I look up above, and again, I find the degree or highest exponent on a variable is 3. And so I have all my different places here. And now I'm going to put in the coefficients for each one. I'm worried this is going to get pretty ugly. Okay, so I'm dropping down. D mama, drop down the first number, and now we're going to multiply. Half of 20 is 10. I combine to get -2. Half of -2 is -1. Combine to get -24. Half of -24 is -12. That doesn't work. Now, I'm going to be lazy right now. I know 1/2 doesn't work. I'm going to change it to -1/2, and I'm simply going to erase this just so that I already did these 6 different ones. It took up a lot of paper, so I'm just going to be lazy here. Let's try -1/2. Move this back in here. Okay, so D mama, drop down. Half of 20 is 10, but it has to be a -10, because ultimately what we're doing now is we're dividing by -2. So 20 divided by -2 is -10. Combine to get -22. If I take -22 and divide it by a -2, I end up with a +11. When I combine a +11 and a -23, I get -12. And now taking -12 and divided by -2, I get a 6. Yes! And I finally found one that works. Okay, so this rational root produces a 0 as the output. That means that -1/2 is a solution. What can I do with this? So I'm now going to write 0 equals -1/2, -22, and +20. The first value to the left of the equal sign has no x's, 1 x's, and 2 x's. And I can see all of these are divisible by at least 2, if not even a larger number. So let's see here. Okay, it can't be divided by 3 or 4 or 6 or 12. So let's just factor out a 2. 10x squared minus 11x minus 6 equals 0. This is what I'm going to focus in on. And let's see if I can solve here by factoring. If not, I will use the quadratic formula. 10 times -6 is -60. So two numbers that multiply, okay, they're going to be different signs. The larger is going to be negative. That would be 15 and 4. Multiplies and combines. So because the leading coefficient is not 1, we got to do a little bit more work here. And you could use a bottoms-up method that I previously showed 2 months ago if that's your preference. I know you all voted, and the majority of you prefer this AC. Prefer this AC plus B method. So I'm going to take the two selected numbers, put them in the middle. Your front and your back goes down, and now I'm going to use factoring by grouping. So I can factor out a 5x, and I'm left with 2x minus 3, 2x minus 3. 2 times 2 is 4 with an x. 2 times -3 is -6. Okay, they both contain a 2x minus 3. And in front of the first is a 5x. In front of the back is a +2. I'm going to set each one of these factors equal to 0, and I'm going to solve. So 2x minus 3 equals 0. Add 3 to the opposite side. Divide by 2. And I get x equals 3/2. Okay, x equals 3/2 is the second solution. And then I have 5x plus 2 equals 0. I'm subtracting 2 to the opposite side, dividing by 5, and I get x equals -2/5. So if I come up top, I have, and I know my handwriting was messy, but I have a -2/5 and a +3/2. These are the three solutions to this polynomial equation.